So this video is on circles and intersecting straight lines. So if a circle and a straight line exist on the same axes, there can be three possibilities for what can occur. The first possibility is that the straight line passes through the circle like this, and it touches the circle twice as it goes through the circle, so therefore there are 2 points of intersection. The second possibility is that the straight line touches the circle once on its edge. It doesn't go through the entire circle like before, but it touches the circle once, and there is 1 point of intersection, and this is a tangent to the circle, and we're going to discuss more about tangents in the next video. And the third possibility is that the straight line doesn't pass through the circle, so there are 0 points of intersection. So we can apply the discriminant to this, which we've seen before when there are sort of points of intersection. So if you don't know what the discriminant is, you need to go back and watch the video on discriminants in the quadratic chapter, the quadratic set of videos. But if we have a circle with equation x minus a squared plus y minus b squared is equal to r squared, and we have a straight line with equation cx plus dy plus e is equal to 0, we can rearrange the straight line equation to make one of x and y or y the subject. It doesn't matter which one, we can do it for x or y, it gives us the same answer. And therefore we sub this into the circle equation. We rearrange to put everything onto one side and make the other side equal to 0, and then we make a quadratic equation, and then we can apply the discriminant. And the discriminant, if b squared minus 4ac for this substituted equation is bigger than 0, there are going to be 2 points of intersection. If b squared minus 4ac is equal to 0, there's going to be 1 point of intersection, therefore the line is going to be a tangent. And if b squared minus 4ac is less than 0, then there are going to be 0 points of intersection. The line isn't going to intersect the circle. So let's do an example in order to show this with numbers. So let's do the circle with equation x plus 3 squared plus y minus 3 squared is equal to 39. And let's do a straight line with equation 2x minus y plus 6 is equal to 0. And we want to find the number of point of intersections that there is going to be between the line and the circle. Well, the first thing we need to do is rearrange this to make x or y the subject. I'm going to do y as it looks easier, we don't have to divide by anything. So it's going to be 2x plus 6 is equal to y, as we put the y onto the other side. And then we sub this into the circle equation to get x plus 3 squared plus y, which we sub in 2x plus 6 for. So it's going to be 2x plus 6 minus 3, which you can simplify to 2x plus 3 squared is equal to 39. Then we can expand the brackets to do this bracket is going to be x squared plus 6x plus 9 plus this bracket is going to be 4x squared plus 12x plus 9, and this is all going to be equal to 39. We can simplify this by collecting like terms to make this 5x squared, this equation down here, I've just had to move it up here, sorry, 5x squared plus 18x plus 18 is equal to 39, and then we bring the 39 onto the other side to make 5x squared plus 18x, and it'll be minus 21 is equal to 0. So I just had to clear some space, or otherwise I wouldn't be able to fit it in. So now we can apply the discriminant to this substituted equation. So the discriminant is b squared minus 4ac, and if we sub in the values, b is 18, so it's going to be 18 squared minus 4a, which is 5, c, which is minus 21, and if we put this into a calculator we will get it out as 744, which is bigger than 0, so therefore b squared minus 4ac is bigger than 0. So therefore we can conclude that for this circle and this straight line there is going to be 2 points of intersections, and it's going to look like this, where it passes straight through the circle. So this is a very common exam question. They can give you the equation of a line and the equation of a circle, and there's an unknown constant in there somewhere, and they tell you how many points of intersections there are. So here they say that the line is a tangent to the circle, so therefore there's going to be 1 point of intersection, so therefore b squared minus 4ac is going to be equal to 0, and therefore using this we can find the value of k. The first thing that we need to do is rearrange the equation of the line to make y or x a subject. It doesn't matter which. I'm just going to do y because it looks easier to do. X minus 16 is equal to y. Then we sub this into the equation of the circle. So it's going to be x minus 4 squared plus y, which is now x minus 16. We sub in this value. So it's going to be x minus 16 plus 6, which is going to be equal to minus 10, squared is equal to k. We can expand the brackets to do x squared minus 8x plus 16 plus x squared minus 20x plus 100 is equal to k. Then we can simplify this by collecting like terms to 2x squared minus 28x plus 116 is equal to k. We can move the counter to the other side to do 2x squared minus 28x plus 116 minus k is equal to 0. And then we can sub this into the discriminant, which we know is equal to 0. So b is minus 28, so it's going to be minus 28 squared minus 4a, which is 2, c, which is 116 minus k, and all of this is going to be equal to 0 because there's 1 point of intersection. We can simplify this. Minus 28 squared is 784 minus 4 times 2 times 116, which is going to be 928, and it's going to be minus 4 times 2 times minus k, which is going to be plus 8k, and this is going to be equal to 0. If we put 784 minus 928 into a calculator, it's going to be equal to minus 144 plus 8k is equal to 0. So therefore 8k is going to be equal to 144, and then k is going to be equal to 144 divided by 8, which you've put into a calculator. It's going to be k is equal to 18, and this is the answer. Really quick, if you wanted to check your answer in some way, what you could do is you could sub the value of k back into this, and then put this quadratic equation into your calculator to find the solutions or the roots. And remember, because it's a tangent, there's only going to be 1 point of intersection. So if your calculator gives you back only one solution, only one value, therefore you know that you've done this part right, as you've only got the one value of x, and therefore you know that you've only got 1 point of intersection, so therefore you've done this part right. So here's a question on circles and straight lines, so pause the video, have a go, and I'll go through the answer in about 5 seconds. Okay, so this is similar to the question before, where we have the equation of a line and the equation of a circle, and we have an unknown constant, but it tells us how many points of intersections there's going to be. It says that the line does not intersect the circle, so therefore we know there's going to be 0 points of intersections, so b squared minus 4ac is going to be less than 0, and it's going to be a set of possible values, not of values of x. It's going to be a set of possible values because we have an inequality sign here. So the way we're going to do this again is we need to make y or x the subject for the line, but y is already the subject, so this is quite useful to us. And then we sub this into the equation of the circle to do x minus 8 squared plus y, which is kx, because we're subbing this into it, kx minus 3 squared is equal to 25. We expand the brackets to do x squared minus 16x plus 64 plus, and then we expand the brackets here, it's going to be k squared x squared, remember you need to square the k as well, minus 6kx plus 9 is equal to 25. We can simplify this. I'm going to put the x squared and the x's next to each other. So this is going to be x squared plus k squared x squared. This is these two bits here. These are the x squared terms, and the x terms are the minus 16x minus 6k x. This is the x terms, and it's going to be plus 64 plus 9, which is going to be plus 73. This is equal to 25. We can move the 25 onto the other side to do x squared plus kx squared minus 16x minus 6kx plus 48 is equal to 0. Now you don't need to do this, but just for simplicity, just to show what a, b and c is, we can just factor this slightly and do 1 plus k squared x squared plus minus 16 minus 6k x plus 48 is equal to 0. This is just to clearly show what a, b and c are going to be when we sub it into this equation here. So I just had to clear some space. So now we put this into this inequality. So it's going to be b squared, so it's going to be minus 16 minus 6k squared minus 4a, which is going to be 1 plus k squared, c, which is 48, and all of this is going to be less than 0. We can expand the brackets here, and it's going to be 256, you'll have to use a calculator for this, plus 192k plus 36k squared, and it's going to be minus 4 times 1 times 48, which is going to be equal to minus 192. It's going to be minus 4 times k squared times 48, which is going to be minus 192 k squared, and all of this is less than 0. We can collect like terms, so the k squared will be minus 192k squared plus 36k squared. Again, you'll probably need to use a calculator for this to get minus 156 k squared, and then it's just plus 192k as there's no other like terms, and then it's going to be 256 minus 192, which is going to be equal to 64, and that is less than 0. Now we've got a quadratic inequality, and we talked about this in the equations and inequality sections, how to solve this. So what we're going to do is we're going to replace the inequality sign with the equal sign. So we're going to do minus 156k squared plus 192k plus 64 is equal to 0. Then we're going to solve this. The best way to do this is just put it into your calculator and solve it, and you're going to get the values of k for this equation are equal to minus 0.27. Remember, we need it to 2 decimal places. Minus 0.27 and 1.50. Then we can just sketch a quick quadratic, and we know it's going to be a negative parabola because of the negative sign here. So it's going to be negative like this, and we know the roots as minus 0.27 and 1.50, and we need to find the values where the quadratic is less than 0, and the values where the quadratic is less than 0 is going to be these values here, because this is when it's under the y-axis, so it's less than 0, and these values are going to be when k is less than minus 0.27 or when k is bigger than 1.50, and this is the answer to the question. The set of possible values of k is going to be when k is less than k is less than minus 0.27 or k is bigger than 1.50.